Hi everyone. Today we are going to explain on this question, which is from the O-level prelim exam from one of the schools. So this is a circuit involving electromagnetic, and in this question, we see that there is a circuit and there is some connection here. So it shows that the structure of a circuit breaker that uses an electromagnet, and the circuit breaker operates when the current is 13 amp. Circuit breaker, it refers to there's a spring here, and when there's a movement from the iron armature, there will be a break, and therefore the circuit will stop. So that is when it's 13 amp. Okay. So the first question, first of all, it asks, mark an arrow showing the force on the iron armature caused by the electromagnet. Okay. Basically, due to the movement of the magnet force, okay, in this way, if you use a rule of thumb for the magnetism, okay, I will show you a diagram on that. Okay, so if you use your right hand and you curl it with the thumb pointing this way, that's a direction of the magnetic field. Okay, so the guideline would be following the four fingers where the coil is moving, and then you will get the direction of the magnetic field. Okay. So if we go back to the question, okay, and this way we will see that the curl and the movement of the current is going this way. And therefore, if you curl your thumb, okay, you can see that the movement, this one is going upwards. The current is going upward, okay, with your right hand. And that way, it actually create a magnetic force, and it will bring down, okay, the iron armature, right? So the answer will be actually the arrow here. So this will be the answer for part one, okay? And for part two, it says suggest one reason why iron bar does not move when the current is less than 13 amp. So basically it's quite straightforward. So when it's less than 13 amp, because according to the question, it says it's operate only when the current is 13 amp. So when it's less than 13 amp, there is not sufficient current, and therefore it's not able to activate the electromagnetic in this iron core. Okay, so we can also have a quick look at the answer here, right? So this is the answer. The magnetic force of the electromagnet is not enough to attract the iron armature if it's less than 13 amp. Okay, so this is just a straightforward answer. And you can see that just now the arrow is pointing down here. Okay, so now the next question. The next question says, when the current is greater than 13 amp, the circuit breakers stop the current. Explain what happens in the circuit breakers when this occurs. So it's a 3-mark question, so we need to write slightly longer. So the current is greater than 13 amp, which means the circuit breaker will stop. But let's study the circuit again. Okay, so it's assuming that the current is strong enough and everything's work, so this will come down, will be strong enough and come down. And when it's pulled down, the iron armature move, so then there's a break. from the spring and the circuit breaker will stop. Okay. So if we refer to the answer sheet here, okay, so you can say that actually when the current is greater than 13 ampere, the electromagnetic force is strong enough to attract the iron armature. All right, so that is what is the outcome. Then you give the reason. Because the armature turns anticlockwise and the spring goes down below the armature and the contact is broken. So there, and then the final thing about the current is that the current stops flowing due to the incomplete circuit. Okay. Okay, then the next question. The next part, state why or state how the electromagnet can be altered or changed so that the circuit breakers stops the current at less than 13 amp. Okay. So state how the electromagnet can be altered so that the circuit breaker stops the current at 13 amp. Okay, so if you look at the